everyone, welcome back to Shrudi's Pharma World. Today I am going to talk to you about emulsion. An emulsion is a dispersion of a liquid as globules in another liquid, both the liquid being immiscible with each other. So here we have two liquid samples. Both are immiscible. One of the liquid is dispersed as small globules in another liquid. Such a dispersion is known as emulsion. Example: dispersion of oil in water, dispersion of water in oil. Both are examples for emulsion. And here the globule size vary from 0.1 to 10 micrometer. The diameter of the globules vary from 0.1 to 10 micrometer. Globules diameter as small as 0.01 micrometer and as large as 100 micrometer are possible in some emulsions. If our emulsions having the globule diameter about 5 micrometer, then it is called as fine emulsion. In fine emulsion, globules diameter will be about 5 micrometer. If our emulsions having larger globules, then it is referred to as coarse emulsion. Emulsifying agent is one of the major ingredients that is used to prepare emulsion. It is also called as emulgent or emulsifier. These are the substance added to the emulsion to stabilize it. Based on the nature of the dispersed phase, emulsions are of two types: oil in water type and water in oil type. So based on the nature of the dispersed phase, emulsions are of two types, and based on the globules diameter, emulsions are of two types: fine emulsion and coarse emulsion. Fine emulsion means it is having globule diameter about 5 micrometer, and if our emulsion containing larger globules, then it is called as coarse emulsion. You all are familiar with this term emulsifying agent. As I already told you, emulsifying agents are the substances that are added to the emulsion to stabilize it. Irrespective of the chemical nature of the emulsifying agent, they tend to concentrate at the interface and form a tough film around the globules. So, what is the function of this emulsifying agent? While adding this emulsifying agent into our emulsion, they tend to concentrate at the oil-water interface and that form a tough film around the globules. So, like this, it protects the emulsion. It prevents the coalescence. So, here you can see different types of emulsifying agents. Based on the type of the film they form around the globules, emulsifying agents are classified: surface active agent, hydrophilic colloids, and finely divided solids. If the emulsifying agents adsorb at the oil-water interface and form monomolecular film around the globules, then it is called as surface active agents. These agents reduce surface tension. Example: soap, span, tween. Next is hydrophilic colloids. These are adsorbed at the oil-water interface and form multimolecular film around the globules. Example: acacia, gelatin. And the third one is finely divided solids. These are adsorbed at oil-water interface and form a particular layer. Example for finely divided solids are bentonite, V-gum. Here you can see different types of emulsion. As I already told you, based on the nature of the dispersed phase, emulsions are of two types. The first one is oil in water type emulsion and the second one is water in oil type emulsion. The first figure that represents oil in water type emulsion. From this figure it is clear that oil is dispersed as small globules in aqueous phase. So the dispersed phase is oil and the continuous phase is water. This yellow color represents oil globules. Oil is dispersed as globules in water. So that is oil in water type emulsion. And the second one is water in oil type emulsion. Here water is dispersed as small globules in oil. Like this, water in oil type emulsion is formed. Here the dispersed phase is water and the continuous phase is oil. So there are two different types of emulsion. One is oil in water type emulsion and the other one is water in oil type emulsion. So based on the nature of the dispersed phase, there are two types of emulsion. One is oil in water type and the other one is water in oil type emulsion. And coming to oil in water type emulsion, as we all know, here oil is distributed as globules throughout the aqueous continuous phase. Such an emulsion is called as oil in water type emulsion. Medicinal emulsions for oral administration are usually oil in water type emulsion. And here you can see various emulsifying agents used to prepare oil in water type emulsion. First one is acacia gum and the second one is tragagan gum, then starch, methyl cellulose, sodium carboxymethyl cellulose, soluble salt of alginic acid and gelatin. All these are the emulsifying agents which are used to prepare oil in water type emulsion. Acacia gum, it has more emulsifying property and less viscosity building property. Acacia gum is used as an emulsifying agent. But tragagan gum has more viscosity building property. It is having less emulsifying property. So tragagan gum is used as a secondary emulsifying agent. Then of course starch, methyl cellulose, sodium carboxymethyl cellulose etc. are used to prepare oil in water type emulsion. Finely divided solids such as aluminium hydroxide yields oil in water type emulsion. Non-ionic surfactants such as tween, natural emulsifying agents such as acacia, sodium carboxymethyl cellulose, these are also used to prepare oral emulsion. Oil in water type emulsion we can also use externally. For example, turpentine vanishing cream. So turpentine vanishing cream is an example for oil in water type emulsion. It is used externally. Surfactants or mixture of surfactants having HLB values in between 8 to 16 that yields oil in water type emulsion. Move on to water in oil type emulsion. As we know, here the dispersed phase is water and the continuous phase is oil. Water is distributed as small globules in oily continuous phase. Like this, water in oil type emulsion is produced. These emulsions are mainly for external use. Example, cold cream, oily calamine lotion, oily zinc cream. Now let's see what are the different emulsifying agents used to prepare water in oil type emulsion. Emulsifying agents such as polyvalent soap like calcium palmitate, sorbitan esters, cholesterol and wool fat. These are the agents used to prepare water in oil type emulsion. Surfactant or mixture of surfactant whose HLB value is between 3 and 6. Then it yields water in oil type emulsion. Now let's study a special type of emulsion which is known as multiple emulsion. These are emulsions within emulsion. It is designated as water in oil in water type emulsion or oil in water in oil type emulsion. In this case, water in oil type emulsion is first prepared and then it is incorporated into an aqueous phase. Like this, water in oil in water type emulsion will be formed. The drug is present in the innermost phase, so the drug must pass two phase boundaries before it is getting absorbed. Both hydrophilic and hydrophobic emulsifying agents are used to prepare multiple emulsion. Water and oil type emulsion prepared by using isopropyl myristate, sorbitan monomolecule and distilled water. Here the isopropyl myristate is used as an oil phase. Sorbitan monomolecule is used as an emulgent or emulsifier. Then aqueous phase is also used. By using these components, water in oil type emulsion is prepared first. Then it is incorporated into an aqueous phase. After preparing this water in oil type emulsion, then it is added to a polyoxyethylene sorbitan monomolecule solution in water. Thus, oil type emulsion is formed. So this is a simple procedure for the preparation of the special type of emulsion, that is water in oil in water type emulsion. This special type of emulsion, water in oil in water type emulsion, is used to provide prolonged action. It is also used for taste masking. It is more effective dosage form. It is used as parenteral preparation. And it provides protection for the drug against external environment and enzyme entrapment. Now move on to another topic, that is theories of emulsification. There are different theories which is coming under this topic. Viscosity theory, wedge theory, film theory or adsorption theory, interfacial tension theory. Coming under this interfacial tension theory, there are two theories. One is monomolecular adsorption theory and the second one is multimolecular adsorption theory. The first one is viscosity theory. Viscosity theory. According to viscosity theory, an increase in viscosity of an emulsion will lead to an increase in stability. So this theory states that increasing the viscosity of an emulsion, that will surely increase the stability of that emulsion. But it failed to explain the stability of milk when it is having less viscosity. This is first theory. Then film theory or adsorption theory. According to film theory, the added emulsifying agent gets adsorbed at the oil-water interface. Okay, the emulsifying agent gets adsorbed at the oil-water interface and it forms a mechanical film. And this film offers stability to the emulsion. But it could not explain the formation of type of emulsion. This is film theory or adsorption theory. Then wedge theory. According to this theory, monovalent soap like sodium stearate gives oil in water type emulsion and divalent soap like calcium stearate give water in oil type emulsion. This was explained by the successful accommodation of soap at the interface and the subsequent possible orientation of the soap molecule to give the type of emulsion. Sodium stearate is a monovalent soap C17H35COONA and it is represented like this. Sodium stearate is represented like this and its accommodation is possible only in oil in water type emulsion. In case of divalent soap like calcium stearate, its accommodation is possible only in water in oil type emulsion. Okay, so calcium stearate is represented like this. It is a wedge-like picture. Okay, and it could not explain the stability of an emulsion. This wedge theory could not explain the stability of an emulsion. And another important drawback of this wedge theory was the calcium stearate ionizes and it will not exist as wedge always. So this is one of the limitation of this wedge theory. Move on to the next theory, interfacial tension theory. Here the added emulsifying agents that reduces the interfacial tension between oil and water phase, and it will produce a stable emulsion. And this theory could not explain the formation of type of emulsion. Interfacial tension theory can explain the stability of emulsion, but it could not explain the formation of type of emulsion. Thus, there is no universal theory of emulsification. Any theory to be meaningful, it should be capable to explain the type of emulsion formed and the stability of emulsion. Now let's discuss about monomolecular adsorption theory. Surface active agents are responsible for monomolecular film which is formed around the globules. Surfactant, these are adsorbed at the oil-water interface and form a monomolecular film around the globules of the dispersed phase. This film is flexible in nature and it acts as a mechanical barrier to coalescence. Hence, the emulsion gets redispersed easily on shaking. So, these are the monomers which are adsorbed at the oil-water interface. Here, water is there and oil is present here. And this monomers, the surface active agents oriented like this. And it form a closely packed film and it form a monomolecular film around the globules. We can use either a single emulsifying agent or a combination of one or two emulsifying agents to prepare emulsion. If only a single emulsifying agent is used in the preparation of emulsion, then it may not be able to impart stability. So therefore, two or more emulsifying agents are used in combination to obtain a very stable emulsion. An emulsifier consists of two portions. One is polar region and the other one is non-polar portion. Polar portion of the emulsifier gets oriented towards the water phase, while the non-polar portion oriented towards the oil phase. Is it clear? So this is oil and here water. Okay, so this emulsifier consists of two portions. One is polar region and the other one is non-polar portion. Okay, so this polar portion is oriented towards the aqueous phase. So water is present here. Here the continuous phase is water and the globule is oil. Okay, so this emulsifier oriented like this. Okay, here you can see how this emulsifier is aligned. The head portion or the polar portion is oriented towards water and the non-polar portion oriented towards oil phase. This leads to the formation of a monomolecular film at the interface. If the film is closely packed, then the emulsion will be more stable. If it is loosely packed, then the emulsion will be less stable. As I already told you about using combination of surfactant or combination of emulsifying agent rather than using a single one to stabilize an emulsion. So it is assumed that the combination of surfactants support each other and strengthen the molecular film. The surfactant blend may consist of water soluble and oil soluble surfactant. For example, a combination of sodium cetyl sulfate, The sodium cetyl sulfate is hydrophilic and cholesterol is lipophilic. Here we are using a combination of hydrophilic and lipophilic surface active agents. Sodium cetyl sulfate is hydrophilic and cholesterol is lipophilic. And these surface active agents form a closely packed complex film at the interface so that it produces an excellent emulsion. This sodium cetyl sulfate is oriented like this. The polar portion is oriented towards water and the non-polar portion is oriented towards oil. Then cholesterol is lipophilic. The hydrophilic region of cholesterol is oriented towards aqueous phase and non-polar portion is oriented towards the oil phase. So we will get a closely packed complex film. It indicates that the formed emulsion was stable. Let's see another one example. Sodium cetyl sulfate and oleal alcohol. The interaction between the surfactants at the interface is poor. So here you can see there is no closely packed film. It do not form. This combination do not form closely packed complex film. Their combination produce very poor emulsion. One more example, cetyl alcohol and sodium oleate. Here a closely packed film is produced but complexation is negligible, so it also result poor emulsion. So these are the important points regarding monomolecular adsorption theory. According to this theory, the surface active agents adsorb at the oil-water interface and they form a complex film around the globules. This film acts as a mechanical barrier to coalescence. Like this, it provides stability to the emulsion. So these are the important points regarding monomolecular adsorption theory. I conclude that according to this theory, the surface active agents get adsorbed at the oil-water interface and they produce a complex film around the globules. So this film which acts as a mechanical barrier to coalescence. This film provide protection or stability to the emulsion. Now move on to multimolecular adsorption theory. As we know, the different types of hydrophilic colloids, acacia, gelatin, tragagan, these are hydrophilic colloids. And these hydrophilic colloids adsorb at the oil-water interface and tend to produce a multimolecular film around the globules. And this multimolecular film prevent coalescence. These agents also reduces interfacial tension moderately. Hydrophilic colloids are effective at high concentrations and it promotes the formation of oil in water type emulsion because of its high hydrophilicity. And the next theory is solid particulate adsorption theory. As we know, finely divided solids such as gum, bentonite, etc. Thus, finely divided solid particles getting adsorbed at the oil-water interface and they form a rigid film around the globules. And this rigid film containing closely packed solids. This film acts as a mechanical barrier and it prevents coalescence of globules. It produces coarse emulsion. Finely divided solid particles produce coarse emulsion. In this figure, it is clear that in oil and water type emulsion, if we are adding surface active agents, then it will produce a monomolecular film around the globule. If we are using hydrophilic colloids, then multimolecular film will be formed at the oil-water interface. If we are adding solid particles, finely divided solid particles, then it will form a rigid, closely packed film like this. Listen, The type of emulsion formed depends on the wetting of finely divided solid particles by either the oil phase or water phase. If the wetting of solids occurs easily by water, then it produces oil in water type emulsion. If the wetting of solids occurs easily by oil, then it produces water in oil type emulsion. Okay, so bentonite, vegan. These are the examples for finely divided solids. These are the important theories involved in emulsification. Hope you all understand. If you have any doubt, please comment below. Thank you for watching. If you are not yet subscribed my channel, please do consider to subscribe and hit the bell button too. Thank you.